important part, finding the POIs, right? So, when it says optimization, it just simply means that at the end we're going to have the best answer, okay? So here we have that a hair salon provides haircuts for children and adults. Okay, the salon books at least 5 adult appointments for every child appointment. There's the word at least. Okay, that's the hint for there's an inequality there. The salon usually books at least 90 appointments per week. So there it is one more time. It doesn't just specifically talk about adults or children, just 90 together. And on average, a child appointment takes 20 minutes, while an adult appointment takes 45 minutes. There's no inequality in there. It's just a note. Among all the stylists available, there are up to 160 hours available to cut hair in this scenario. Define your variables and state your implicit constraints. The first X would be number of children cuts, right? And Y is number of adult cuts. Don't forget about this. Okay, and we make a note that this is discrete because that will come in once we come up with the POIs. Okay, develop a system which accounts for the restriction of this problem. This is the beauty of this part, guys. I don't want you to freeze. Okay, it's okay. Come up with your inequalities. I will follow through on the graph. Even if you get this wrong, you can still score marks if you're consistent. I just want to see, do you know how to work with them? Okay. So the first one here, at least 5 adults for every child appointment. So this is adults, right? These will be the children, and so you want this to be greater than or equal to, right? And the 5, you put it here in front of the children appointments. When we did the whiteboard work, we did one of those, right? I think we wanted twice as many vans compared to cars. So it seems counterintuitive, but it says, right, this is supposed to be 5 times what the children number is, at least. Okay, so it could be exactly 5 times or more. Okay, so this is inequality number 1. You get a mark for that one. You know what? I'm just gonna go like this. So try to be wise with your space. It books 90 appointments per week. So that's where at least 90. That's your next inequality. That one, I feel like you should have been able to get that one. And then among all the stylists, there's 160 hours available to cut hair, and we're told what it takes in minutes. So either you turn the minutes into hours. I usually go and turn my hours into minutes. So I'm just going to quickly do that here. Okay, 160 times 60, that's 9,600 minutes. Okay, if you want to convert that real quick. So using the minutes, 20 minutes for children's cut, 45 for an adult. Okay, and that has to be less than or equal to 9,600 minutes. Okay. There's your third mark. Where's the half come from? You somehow showing me that you've converted. So either 96 just shows up, I'm fine with that, or you actually do the work somewhere on the side. All right, now we graph it. And these ones are somewhat challenging to graph. This one in particular, but I'll show you the trick. X plus Y is greater than or equal to 90. We'll do that one real quick. The x-intercepts and the y-intercepts are going to be exactly the same. It's going to be 90, 0, and 0, 90. Just make it small, right? Don't use up too much space. We rewrite that real quick. We bring the x over to the other side. Now we know it's solid. True is above because it's greater than. And we're going to shade the opposite. We're going to shade out the false region. So we're using reverse shading. There we go. Next one. This one, if you have space on the test and you want to do it right here, I'm okay with it, like rewriting and finding the intercepts. How about I do that? X-intercept, Y-intercept. I will fast forward a little bit here because I know you know how to do it. So the x-intercept is 480, 0. And the y-intercept, if you let x equal 0, is going to be 0, 213.33, and that keeps going, but that's okay. You just round. Because this is for graphing purposes. Okay. Next, let's rewrite this thing. How about we rewrite it underneath here? So that'd be 45y is less than or equal to negative 20x plus 9600. Divide everything by 45. You get y is less than or equal to. Watch what I do here. I just leave everything as is. Because you don't get a whole number when you go 96 divided by 45, 9600, I should say. So I'll just leave it like that. Okay. I know this is solid. True is below the line. So I need to shade above the line. So make sure you tell yourself everywhere what it is that you need to do. Okay. And then this one. The pain in the butt one, right? This one, you don't want to find the intercepts. It's going to give you 0, 0 every single time for both. So what we're going to do here is we're going to let x be something of your choice. You got to be smart about this. Would 1 make sense here? Let x equal to 1. You could do it, but look at the numbers that I'm looking at here. Like, right, 90s, 480. So you can make it be 100 or 50 or something bigger than just 1. Okay, so I'll let it be 100. That means that y, right, if you plug in x there, y will be 5 times 100. So that's 500. So you found your second point. You're going to connect 100 and, right, 100, 500. That is your point that's going to connect to the origin. Okay? Next, this is going to be a solid line. True region is above, shade below. Now we're ready to go. So I'm looking at my intercepts. My x-intercept, the biggest is 480. So I'm going to go 1, 2, 3, 4, 5. That's a little bit too small. I'm going to go up by 100. And use up your axes if you can. 1, 2, 3, 4, 5, right? And you don't need to label every single marking if you don't want to. And then all the way up to y-intercept is 213, and I've got a 500 here as well. Right, so I'm going to go to 500 here. 1, 2, 3, 4, 5. The nice thing is I'll give you grids on the test and on the exam, so you're not going to have to make your, like there's going to be nice boxes in there. If there aren't boxes, then you just make your own markings. So this would be number of kids cuts, and this would be number of adult cuts. Make sure you get all of this out of the way, the labeling and everything. You don't want to lose marks there. So let's do this one, 90, right? So 90, 0, and 0, 90. It's a very small line that shows up. That's okay. Let's label it outside. X plus y greater than or equal to 90. Maybe yours is bigger because you used a different scale. That's fine. Next is, let's do this one. So this one you connect 0, 0, and then 100, 500. It's way up here. So it's actually a line that goes up, and there, yes, you put an arrowhead into that one. So that's y is greater than or equal to 5x. Not very popular, by the way, this one, on tests and exams, but you still need to be comfortable with it if you need to work with it. Okay. Next is this one, 480, 0, and 0 to 13. This one, right? So I'm going to connect the line right here. and this is going to be a 20x plus 45y is less than or equal to 9600. There we go. Now shading. I'm shading below this small line right here. So that's all gone. I'm shading below this one. Which way is below? Always think of your y-axis. This is above and this is below. So below is here. You're supposed to shade this section right here. Just don't leave this blank, okay? Even if you think something isn't right, the worst thing you can do is leave everything blank. That's not going to help you at all. The next one is shading above. So we shade above this line. So everything above that line is gone. Okay, so this is your solution region. Right there, it's very small. And it is surrounded by these two corner points, as well as we need to figure out what this one is and this one. It's asking for the corner points in C. So let's go ahead and do that. Enter all of this into our calculator. I already went ahead and did that. But for your window, folks, this one is the easiest one to do your window because you already know, right? You've done all the work. So just let this be your X max, and whatever you have on your Y axis, that is your Y max. And then you hit graph. This is what I get. It does match this scenario. Okay. So I'm going to now find these two here because I already know the intercepts here. I calculated them already. So I'm going to do these two. Second trace 5. I'm on the blue right now. Let me see if I can make this appear. It doesn't have to. As long as you're on the blue, you hit enter. Circle to you get to the black line. And so one of them is 3918, 195.92. Okay. So I'm gonna label that 3918, 195.92. Can you see that? You have to round that one. So I'm going to go ahead and round it right away. That's 39,196, comma. Let's find this one here. Go second trace 5. It's between the blue and the red. So enter at the blue, enter at the red, enter again. That's 1575. Perfect. And there is this intercept here, which is 0.90, and there's this one over here, which is 0.213.33. Can't have that. You need to round to 0.213. I would round down in that case. Okay. So here are the 4 corner points. 1, 2, 3, 4. Okay. There's 4 points surrounding my solution region. State the objective function that would determine the total time. I told you to change this to time. The salon spent on styling hair. Let's call this T for time or H for hours if that's what you want to do. And all you need to do is, we're talking about time, it'll be 20 for every kid's cut and 45 for every adult cut. That's what I would. This one you could have done even without solving the system, honestly. This one right here. Okay. This is the time. Can I just do an aside here? If it asked you for number of cuts, how to get the most number, most number of cuts, you would go C. It'll simply be X plus Y. Right? If you add up the cuts here, that would be the objective function that would tell you the number of cuts that were produced or that were completed. Next, which combination would result in the greatest time spent? I think I'm just going to give you the key on this one, just to save us some time. And it's posted as well. So what you do is you plug in every single corner point into your objective function and see which one gives you the greatest time spent styling hair. So I did that. And it ends up being the 39,196. I get exactly 9,600 minutes there. So your final answer should be either put an arrow to it and say this is the max. Ideally you say, like, what do these numbers represent? Cutting 39 children's haircuts or children haircuts and 196 adult haircuts will maximize the time. Okay. Backside, let's see how you did there. This one should be very doable. You see what kind of shading has been used? Reverse shading, because your white part is the solution region. So we've got line A, which one is, this one is A here. Let's do that one first. Solution is above and it's dashed, so I go Y greater than. What's the slope here? I'm going to use that point because I was given that. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Actually, it's 70, right? Did you catch that? 70. And 1, 2, 3, 4, 5, 6, 60. If you went 6/7, you're actually okay because you're reducing the fraction, right? But technically 60/70x plus 10, right? It's going through 10. So that gives you, I'll give you 2 marks again. 1 mark for the first part, 1 mark for the second part. Line B and C should be fairly straightforward. B is a vertical, so you know it's X. True region is to the right, and it's dashed, so I leave it like that. It goes through what? -120, correct? So there you go. Line C is the horizontal. Solution is above, so it's going to be greater than, and it's solid, so I put the equal sign. It goes through -20, so that is the inequality for line C. There you have all 3 inequalities. How many POIs does this system have? It actually only has 1 here and 1 there, that's it. In this case, the y-axis does not count because it's, right, it just continues on. This is not a boundary. Okay, this is not a boundary because it's not a word problem. So if you figure out these two, this one, to be honest, you could have just looked at the graph. -120, -20. So if you have that one, you get 1. And to get this other one, use your calculator. It's -35, -20. If you enter all of these into your calculator and just find them using second trace, you should be able to intersect, I should say. You should be able to get it. If you guessed, I won't know any better. So you still get the mark, okay? All right.